Okay. Today we'll look at filiform corrosion. So what is filiform corrosion? Let's look at one video. And if you're driving car or you are in a, if you're passionate about car, then this video will be for you. Okay. Okay, so we will watch what this video.
The first example I'm going to show you is one which you should all be familiar with. This is a section, a piece of an alloy wheel from a car. Obviously, it goes all the way around like that. Now, the alloy wheel is made of aluminium alloy, and it's painted. It might not look as though it's painted, but these dark colours are from the powder coating, the paint powder coating that's put on the wheel for corrosion protection. When you bump your wheel against the curb, it damages the paint system and the wheel starts corroding. And we've shown this here by damaging the paint coating artificially and exposing it to the atmosphere, and we get this very pretty corrosion, which we call filiform corrosion. It is, of course, not damaging to the mechanical properties of the wheel. The wheel is perfectly okay, but it is damaging to the aesthetics of the wheel. So this is an example of corrosion that does not cause mechanical damage, but cause aesthetic damage.
Okay, so based on the video that I showed you just now, so filiform is not like other corrosion. Filiform, it form at the surface. And let me show you another video. This one on the ion, where you will see under microscope, you see how the filiform was created. Let's watch one more short video. So this is under experimental, and you see the changes of behavior. This one from the top, a view from the top, and you'll see some changes about all the lines and all this. Okay. Later we will look at the theory part. What is all these things? Okay. So let's watch this video one more time. I want you to pay attention to the change of the graphic here. And I want you to pay attention to the time on the far left corner. So let's see, as the time change, what happened to the surface. Okay, what happened to the surface? And later in the theory part, we will discuss about the cross section. We will cut away this specimen, and we'll see what happened to the head and the tail. So later we will name this one as your head, and this one is your after the head. This section we call it tail. Okay, let's watch this experiment clip one more time. The time unit is in hour. Okay, so this is what they see at the end of the experiment. So just now I show you the video. Now the first definition, or the first introduction to a filiform. So as you can see from the video itself, you know that filiform is having a warm light. It's a warm light visual, that you see some warm crawling across the surface, and it happened just now in the first video that I showed you. The filiform corrosion happened on the surface. All right, and we can explain the behavior of this filiform corrosion using environment effect or micro environment effect and EPH diagram. So in previous lecture, we have some brief introduction to EPH diagram. What are the axes and what are the region of the pH diagram? And even I upload the appendix for the electrokinetics or the EPH diagram document in the MS Team. So you can go and download, and I ask you to go and read about it. So later we look at environment effect and EPH diagram or potential pH diagram. Okay. Okay. Filiform corrosion, as you can see, is a localized corrosion. Okay, it's a localized corrosion where it starts from one spot and then it crawl and expand to the next destination. Right. However, it still happens at the same surface. All right. And the first video show you that just now the wheel rim having the Filiform. So it actually happened under coating, right? Under coating. So Filiform, the definition of Filiform is that it's a localized corrosion, worm-like, this one, worm-like visual appearance, and it usually happen under coating, right? So the word coating means if you have a element and you put a layer of protection layer, or you put a layer of paint or liquid, that one we call coating. Okay. Why we need to pay attention to Filiform? Because daily life, you know that we use a loss of metal element, with loss of metal element with coating. For example, the drink cans that usually we will see in the supermarket or super mall. Most of them they make of aluminum, steel, and they have a layer of coating or the paint for the either outside or inside. Inside you have a plastic layer inside if you are talking about drinks. Okay, so that's why Filiform corrosion is quite critical if you work in the food industry that involve with coating, and also the metal element. Okay, so that is the motivation, or that is the reason why Filiform is so crucial, that we as an engineer, we need to know about some basic about this type of corrosion. All right. All right. Now another type of another environment that trigger the Filiform is somewhere near to the sea. Okay, for example, the seaport, the warehouse, especially if your friend or yourself, you have a house near the sea, near the beach, you will see that the metals component of your house, they will have all these worm-like, it's not correct, but worm-like form of cosmetic defect on the metals, rim, metals handle, and all this. So this is the environment that given the advantages to form the Filiform. Okay, so okay, this is one of the example. Okay, so this slide is more about the second video that I showed you just now. That you will see some experiment that you see the black dot head and the white tail just now. Okay, so there are some region that we need to pay attention, because when you explain to people about Filiform, these are the words that we use. These are the words that we use, especially when it comes to your test or final exam, even your assignment. These are the keywords that I expect you to put inside your answer, right? So when you explain about Filiform, you need to explain the structure or the arrangement of Filiform. First, Filiform start with the head here. In the second video just now is the black dot just now. You start with the head, and this one view from the top. Later we will dissect this one, and then you'll see from the side what happened inside or the element here. So we start with the head and tail. The head you draw as a teardrops here, and then tail is like a river. Okay, so filiform, you start with the head in the tear form, and then you continue with like a river form of tail. So you have head and tail, and then there's a region between head and tail. We call it the back of the head here and the front of the head. So there are some reaction at the head section, and there are some reaction at the tail reaction. So there are some product over here, there's some product over here. Okay, so the head of the tail here and the back of the tail here. Later, we will show what happened to all this region using potential pH diagram. Okay, so you need to pay a little bit attention to the section that we're talking about, the area we're talking about here. So later you need to visualize where is the location of all these things. So later when you mention head, you have to know, oh, where is head? Back of the head, where is it? Front of the head, where is it? Or where is the tail section, for example. All right. And filiform, you have a direction. So the head will lead the direction of the corrosion. Okay. The head will lead the direction of the corrosion. And another keyword here is coated alloy or coated metals. Right. Remember, filiform, there's some keyword there. Filiform, warm light form, coating, localize. Yeah, these are the things. Okay. All right. So any question on this diagram? Any question so far?
No questions, sir.
Everyone good, eh? Okay. So, okay. Have a look in this diagram. So later I will show you the dissect of this one. We will cut across this one, and then we will see from the side what happened under the head or inside the tail here. Okay. Okay. Memorize this one. Okay, this is just an add-on. Okay. So between the head and the tail and the head, the active region or active corrosion area is this one. Okay. This one is just an explanation, right? After you have all the active corrosion, you know that chemical product after a chemical process, after each chemical process, you have the species or you have the product of the electrochemical process. It will left out over here, and it will be considered inactive. So active part is here, inactive part is here. So if you want to handle this kind of filiform corrosion, you focus on the head because it's like putting out the fire. So this is the active fire region. So if you want to handle this kind of filiform corrosion, you need to pay attention to what happened to the head here. Okay. So I'll show you another video. This one is a very extreme example that happened on aluminium. Okay. So as you can see here, a normal metals filiform corrosion that I showed you in the first video, it won't see like a Christmas tree like this. Okay, but this one is we call what? Is extreme. It's an extreme example for filiform. This one happened on aluminium. Let's watch this short video.
Here we have a lovely example of filiform corrosion taking place on the surface of a freshly broken piece of aluminium. The aluminium had suffered mercury liquid metal embrittlement, and when washed and examined under a low power microscope, it was noticed that the aluminium was reacting with the wet mercury to form tubes or filaments of aluminium oxide. The video was taken using a handheld digital camera which just happened to be available at the time. We've speeded up the video to better illustrate the effect. Unusually, the filiform corrosion is producing filaments coming off the surface. This is probably because there are tiny droplets of mercury causing the corrosion to take place, and the corrosion product is forming right around the droplets as a ring. As further corrosion takes place, this ring is continuously pushed away, forming the tubes observed. To learn more about how you can maximize your key assets, visit our website ax-ea.co.uk.
Okay, so just now this video, you can see that the aluminum filament, this one, the tail, was coming out from the surface. So again, this is a very extreme example. Huh? So for normal cases, you won't see this one. This one happened on the aluminum, and you initiate the process using acidic solution. Then you fast forward the recording process. Then you'll see all this come up. Okay, all right. So this is a diagram where we dissect the diagram just now here. All right, we dissect the filiform corrosion site. And let's see what happened over here. So you have a top diagram and below diagram here. So again, identify where is the head and tail section. So the head is in the front, tail is at the back, and the direction of Filifield direction is following the head. Okay, and you have the section before the head, or in front of the head and after the head, behind the head. And what happened to the tail? If you refer back, this is from the top. This is this section is from the top view, and this is the section view. Okay, so as you can see here, if you draw section view, remember for filiform, the important layer that you should include in your drawing is the coating area. Right? Because filiform happen under coating. So remember to draw this line and label as coating. All right. So if the question give you a diagram, give you a photo, and it mentioned that the surface was protected by a spray coating. So you just change this word to spray coating, and then you explain how filiform can form on that diagram. Okay. Okay. So under coating, let's see the product first. Let's see the tail. What happened after the head was had passed through the location. So, okay, let me have some water. So this one, this side here, you have a stable corrosion products. And in previous lecture slide just now, you know that tail is a stable region. This one, or inactive region. The head is active region. So at the tail, you have a stable corrosion product here. All right. Now, what are the product here? We have covered how to do the electrochemical equilibrium equation in the previous class. For example, metal plus water plus oxygen, what happened to the end product? You get, for example, ferric hydroxide or ferrous hydroxide, ferric hydroxide, and so on. Okay, so this is a stable corrosion products. And you see the arrow here means here the oxygen will go in here. And there's a region here as you near to the head here, especially here, you have a high pH here. What I mean by high pH? Your pH value neutral is 7. And the lower you go, if you watch the video, so this side will be to the right. So from 7 to the right will be alkaline, right? So 7 until 14. This one will be alkaline. So this one will be the higher pH side. So near to the tail, you'll get more alkaline side. And by the, if you see this diagram, if you see the head, all right, apologize for my limitation on my green screen. I cannot go further. All right. So as you can see, at the head there, far left there, you see there's an arrow pointing to the low oxygen, low pH, meaning at the head there, you become more acidic at this side. So this is the head. So you have the region, especially near to the head, the active region. You will have a low pH, mean you're near to acidic region. And from the previous class, we know that corrosion can trigger or become more active when you have acid or acidic environment. So you will see there's a different region of the corrosion. All right. So all these happen between the electrochemical process. So as it passes through, as this Filliform pass through the surface, you see that the head will continue to corrode or eat up or take out the element surface material using acidic environment, and is passed on after the head section, or between the head and tail section. There's an intermediate section there. It will become alkaline. And after it passed through, after a few hours, the products will become stable. The products of the corrosion will become stable and active. Okay, and it will be, and here it will become like a tunnel for the corrosion to get oxygen in. So because this one is like a tunnel already, there's a space here. So when you have space and you have the porous product here, this porous product, and you have a hole here, so as your head advance, you will have oxygen coming in from the back here. All right, this is like, you imagine this one is the opening of the corrosion. So the oxygen will go in through the space of all these products here, and then supply the oxygen to make the corrosion even faster. All right. So you know that corrosion can happen with water, H2O, hydrogen, and oxygen, plus the metal. And if you plus the pH, lower pH or acidic solution, then it becomes faster and faster. Okay. So, okay. Any question on this diagram? Any questions so far? I think it's clear, right? Stop me if you're not able to visualize or see the process over here. Okay.
Yeah, it's good.
This,
Sir.
yeah, go ahead. Anything?
No, sir. It's okay for us. Sir.
Okay, good. So these are all the, just a side note now. Okay, remember that corrosion, when there's a corrosion happen, there will be a different potential site happen. You have anode and cathode. Anode and cathode happen. So when you have positive negative side, then you have a cell happen, and this one, yeah, this one is just to tell you how the process happened. Okay, so at here you have a chemical process happen here, and this one already happened, already explained. So I highlight with the yellow color and so on. All right. So as long as you understand this diagram and you're able to explain how Filiform happened, what happened to the head, what happened to the tail, where is the region of acidic, what happened to the alkalic, where is it the region, as long as you can identify, then you're okay for the Filiform corrosion. So these are the products. So at the head there, you have anodic metal there. Okay. At the head of the corrosion, you have an anodic metal, this solution site there. Okay, I put a special note there. For ion or Fe, pH level at the head there, through experiment, they found that it's between 1 and 4. Depend on the type of the environment you have. And the potential is close to 0.44 volt. The potential at the head. And for the green color, they estimate the cathodic reaction at the back of the head there. The pH will be around 12. So can you imagine the drastic difference between the head and the in front of the head and back of the head? It can change from, let's say I take the 4, pH 4 until 12. So it's quite a big difference from in terms of pH. And when you change the pH, you have different products will happen. Okay, and when you are given a pH diagram, you should able to identify where is the process happen. Right? So for metals, again, these are the reference value for you to plot the corrosion, filiform corrosion on the pH diagram. So these are the reference value for you. You can use 1 to 4 for the head. You can use pH around 12 for the process at the back of the head there. Okay. So you have two number, three important number. One is for the head, you have 1 to 4 pH value, because you know that pH diagram, y-axis is the voltage, x-axis is the pH value. So by using these two, you can identify the spot on the pH diagram. So you have 1 over 4, you can draw a region using pH axis, and then you go to the potential 0.44 volt over there, you just draw, and then you have an intersection point. So you will see where is the region there, and then there's a process happen over there. Then here for catalytic, then you using the same voltage value here, using the same voltage of this one, you extend to pH value 12, meaning on the pH diagram. So you're using the pH value and the acidic and alkalic value. You have two intersection points on the graph, if you can imagine. Okay. All right. So these are the pH diagram that I mentioned just now, and this is the diagram that I showed you just now. Okay. So now what we're trying to do is that we relate what is the physical chemical reaction over here, we relate to the graph over here. Okay. All right. So of course there are some information over there that already plotted for you. Okay. Originally you only have the P axis and pH axis, and all this line you find through experiment. All this region, we call it boundaries of all these products. Okay, this one is a boundary of these products and boundaries of that products. And the line of A, B also defined through experiment. And we already explained what is line A, what is line B previously. If you can't remember, just go back to the previous lecture slides to see them. Okay, so try to relate this one and this one. First, we go for the head first. Just now we have these two values, right? So we have the pH value 1 to 4. So you go to the diagram there, pH 1 to 4, and you are given a potential value 0.44. So you go to the y-axis 0.44, and this one is the positive value. Right? Let's see if I think I miss out the negative. I think I miss out the negative here. Right. So again, I think I miss out the negative here. If I refer to this diagram, the value of 0.44 is negative region. So I believe I have a typo error here. I miss out the negative sign here. Okay, so make some notes at your side. I think there's a missing negative voltage here. So by using these two value, we try to identify where is this value, combination of these two value on the graph. So by using the negatives, again, there's a typo error, negative 0.44 volt, you go to the potential axis, you identify where is 0.44. So here roughly, you can see is roughly near to 0.4 voltage there. And then where is this pH value? 1 to 4. So you identify where is 1 to 4. Again, the yellow region box is just to highlight to you. It just highlight to you where is that line. Okay, where is that line? So during the test of final exam, we will give you all this value, and you need to draw where is the region. Okay, where is the region? So since our exam will be conducted online, all this graph will be, if this question come out, if this question come out, the graph will be given before the exam. So you need to print out the graph before the online test or final exam. You need to print out, and then you use the graph to answer the question. Okay, so that is the way how we do it lah. So yeah. But when you come back to campus later on, all right, then you will see this one physically in the exam hall, right? Okay, we continue with the yellow region. Again, the yellow box is just a highlight. So what in the exam or test, don't give me the box. Don't draw the box. What I expect from you is just draw the bold line like this one. Okay, don't draw this one. Don't draw the yellow box. Yellow box is just I show you where is it in this lecture. Yeah. In test or final exam, don't draw the yellow box. Don't draw the yellow box. I expect you to only draw the line. Where is the corrosion happen? Okay. All right. Anyone you still blur, don't know how to draw this line? Any one of you? You still don't know where to draw this solid black line there? Ask me now, if you don't know how to draw the line here from the chart given, from the table, from this graph given. Okay, so again, from the value given, you identify where is the location, and then you draw the line there. Okay, so this is the first steps. You identify where is it. Okay. Now, as you can see, where is this line located on this graph? You can see it fall within this boundary, right? On the left hand side, you see that on the left hand side you see the Fe2 plus, right? So Fe2 plus is the area where you have the ferric charge 2 positive. This region, you will see you have a positive charge there. And then you go back to the previous slides when we discussed about the corrosion process, where we talk about polarization, we talk about how the ion charges mix with oxygen and become another product. So this is the process where that yellow box happened. Okay, because you have the element, you have the resources to trigger the corrosion. Okay, so again, This one is a acidic region. Right? From the graph itself, you're able to explain a lot of things. Huh? Okay. So again, this is the active corrosion site at the front. Okay, active corrosion site at the front. Okay, yeah. So make sure you know where to draw the line by the value given. Okay, actually this is just a bonus marks lah, right? It's very direct. You extract information from here, plot on the graph. We see the line, we give you marks. Okay, so again, just for information, you won't see this value in the exam because I already show you how to plot. So you should know how to plot when we change the value here. You should know where the line will go. Okay, yeah. Again, the scale and the pH when we give you in the test and exam will not be the same. So you need to identify the region. Sometimes we give you positive charge, sometimes we give you negative charge. So it can go up, it can go down, depend on the value given. Huh? All right. So again, now ask yourself, are you able to draw this solid line if you are given the value over here? Again, there's a typo error here. It should be negative, right? So if it's positive, then it go up there already. It go up to this. This is negative region. If this one, if you follow this slide positive, it should not be there. It should be go up there. Okay, just for info. Then we look at this site, the region behind the head here. Okay, so as you follow this dot line, as you follow this dash line here, the process from here to here, actually you follow the yellow box, then you follow the arrow to the back here. Okay, this is how you read pH diagram. When you identify the head, you fix the environment, the solid black line there, and then you use your ruler. Maybe you can use a soft line, like I use a dash line here, and then you explain the process from here, what happened in here, what happened to here, what happened to here. So you know that this is the behind the head here. Okay, behind the head here. So we are giving you one value of pH at this site. Let's say I give you 12. Right? So how you plot the second point for this region? You follow this dash line from the first site, from the head there. You follow this line, and then you do the intersection point of pH 12 that given in this slide. Of course, in test and exam, we will change this value lah. So 12, you go up, intersect with this dash line, you get one spot there. Okay, you get one spot there. Then this is the spot where this happened. So again, once you stop, you find this spot, you have to identify what is this environment you have. Okay, on this environment, you see that there is a region, right? Now you study material before, right? Material module before, when you study about the metal phase diagram, you do the same thing, right? Metal change from alpha, beta, and gamma phase if you change the temperature and so on. So this will be the same concept also, but now it's more on the pH and P and pH diagram. So once you identify what is pH here, following this dash line, and then you stop at that point, you can use cross symbol or you can use a big circle to identify point B. So in test or exam, I identify this one is A, this one is B. Okay, mark A, B in the diagram. So you label this one, the solid line, as A, this one as B. Of course, if the exam using A and B line, you will not confuse you. We will use other parameter, right? Maybe I'll put this one as P, You identified P point on the graph. This one is Q. You identified where is the Q on this graph. So then you read from this graph. You explain what happened at this site. So as very direct from the graph, you know that on this one, this environment, you have FeOH3. Let me see. Okay, FeOH3 is a ferric oxide, and already tell you the color of this one, right? So we expect something. Expect some question asks you, what is your observation? What is the expected results? What is the color of the products will form at site here? So you in the earlier lecture, we already tell you the color of this one, right? So how this one form, we already tell you, right? So the question can extend from one single diagram, one graph, and then ask you to explain what happened to this site, how this FeOH3 happened. And then you think back, okay? You go back to the process that we discussed previously, how this one happened. Okay. So at this site, you will see the orange color because this is FeOH3. You have an ion 3 products here. So at this region, you will see chocolate color or orange color products over here. And of course, the pH here is higher, and you have a cathode here. So you have to think back, what is the catalytic reaction that we discussed earlier? What is a catalytic reaction? You go back to the previous slides that we discussed earlier when we discussed about catalytic reaction. What is the anodic reaction? So it happened from anodic to catalytic reaction that we. Okay, so you try to link what you learned, what have you learned in the previous lecture. Okay. Any questions so far? Any question on plotting the points from head to tail or head behind the tail? Any question?
No question, sir.
Clear?
No,
Okay.
sir.
All right, good. Okay, so I identified with the green box. In exam or test, don't draw the green box. I just highlight for you for the lecture, for the clarity of the lecture. Okay. So this is just what I mentioned just now. Okay. And this one. So you can see that at the tail here, as you go forward, if you go along this line here, so you go along this line here, you have a stable product here. So here, what can you expect over here? For example, the question, the test question asks you, what can you expect? What are the chemical product that we can expect in region, let's say PQR? What can you expect in the region of R? By looking at this diagram, you continue with this line. So this line, all of it, you having a ferric oxide 3. So the answer we expect from you is ferric oxide will be at this section. Okay, quite direct, huh? There's no complicated things. As long as you understand the relationship between this diagram and this diagram, and then how to plot the line, how to plot the location, and then read from here. Okay. Yeah. Okay. Let's continue. Okay. So this is another diagram on aluminium. So again, when you're given a diagram, read carefully on the axis and pH value. This is also potential pH value, but different material. So here you're seeing the region of chemical product here. pH value, aluminium, aluminum plus, line A and B, right? Again, if you don't know what is line A and B, go back to the previous lecture. You have a product here, you have a product here. ALO2, aluminum oxide. So the black arrow just to tell you if you're given environment so and so, And then where is the head, where is the tail, what happened to the process. Okay, what is the, for example, I give you this diagram and I ask you to explain about the process from point P, I mean the dot there, the dot on the far left there, to the arrowhead. I label maybe that one is Y to X. All right, the dot there is Y, the arrow maybe Z, Y to Z. Explain the process using this diagram. What happened from the point Y to point Z? Are you able to explain? What happened to the environment? What happened to the pH? What happened to the potential? What happened to the products over there? At site, so you explain, there's a structure of answering. For example, you explain what is the environment. You look at the environment, you explain about the environment. So in this case, you're having the dot on the left there, you explain what happened to the pH value over there. And then you try to link what kind of corrosion that having this environment, what will trigger? What kind of corrosion will trigger? Right? So this one fall under Filiform. So Filiform, what happened? What happened to the head and tail? So you explain what happened at the head, what happened at the tail. So are you able to explain using schematic diagram? So schematic diagram, if the question asks you to draw a schematic diagram, it means something like this. It means something like this. We expect you draw something like this, but using pH diagram, meaning you reverse the process. Just now we explained from here to here. The exam or test might be from here to here. What they expect, you read from the graph, you draw the diagram and explain what happened to the head, what happened to the tail. This one is metals. Of course, you know this is metal. Once the information is in the class, we won't repeat the information in test and exam. So go and find out other material. What happened if we change the material? Are you able to relate the principle? Okay, yeah? Okay. So this is another example, aluminium. So here, from the graph, if I say that the head having 0.73, you should be able to relate, right? So if you look at this statement, are you able to relate this statement with the graph? Okay. So you have the, if we mention the head having a potential of 0.73, are you able to relate to this point? Right, you should be able to relate to the dot point there. Yeah? Okay. Then from here, you can. This is just an experiment. This is very small differences between the head and the tail. So this one doesn't matter. This one is just if you give you the differences, how you plot is that you just, if you give you one value, you know how to find differences, right? If you give you 1 point and then they give you differences, you should be able to adjust the point differences, right? Now, for example, this one, you have the starting point of 0.73. You're given the positive changes of 0.09 volt. So the changes, it will be, sorry, again, I think I miss out the negative sign here also. Okay, because from the graph itself, the dot point is negative region. So again, apologize for my typo error. There's a negative sign here. Okay, there's a negative sign here. So you plot the negative 0.73 location there. So if you have a differences of positive, it means it will go up a little bit. It means the arrowhead, maybe I show like, sorry, I should show like this. Okay, so it means that my finger here is the arrowhead. So this is 0.73 here. So what happened to the arrowhead if you have a 0.09 difference? It will go up a little bit because this one is negative. Negative value, you plus a positive value, you have a negative how many? 0.64. So the arrow will go up a little bit. Okay, the arrow will go up a little bit. So you should know how to plot the second arrow. If you're given the 0.9 volt differences. Any question from here to here? You know how to plot the dot to the arrowhead?
No question, sir.
Can how to relate this information and find the graph? Can So if this one come out in the exam test, I expect you to able to answer. So again, of course, if I give you a diagram, I'll give you the value of the arrowhead and the starting point there. So then you explain what is the differences. Okay, the question will guide you. Like for example, what is the differences between the head and the back of the filiform corrosion, depending on this diagram. So I give you the starting point and the last point. You should be able to find the differences voltage. Okay, again, there's a negative sign here. Apologize for my typo error. If not, this one positive, it will jump up to on top already. Okay, so there's a negative sign there. All right. So you draw the line just to explain the process. And from the head there, you know that from the head, the dot there, you project down, you know that the pH value is acidic. Okay, you project down, you know that it is acidic region. What is the value of pH at the head? And what is the pH at the tail there? Okay. So I plot the orange color line for you. And then you move on this dashed line to explain about the process. What happened, especially this line will help you scratching the schematic diagram. Okay, the cross-section diagram for the filiform corrosion. Okay, you should identify the head, tail, what is the pH value at the head, what pH value at the back of the head, and what is the product behind the tail or at the tail section. Okay, this is just a further explanation. Where is the active site? And then what happened to the tail? Okay, what happened to the tail? So I just highlight the arrow. From the arrow, you're able to explain a lot of things. All right. So again, the whole line here is below line A. All right. So line A is a hydrogen evolution line. So this is the process of hydrogen evolution. The whole process happened below this line A. So as you can see from this behavior, as is below line A, we can conclude that when it's happened in aluminium, hydrogen evolution can happen in aluminium. Okay, just a reflection. By looking at this information, relate aluminium and line A. I go back to the metals. Go back to the metals diagram. Up to which point the hydrogen evolution stops? Are you able to identify? By using the information that you received just now on aluminium, I extend the question. Ask yourself as a reflection for today's class. By looking at the ion or the ion pH diagram and the value given on these slides, are you identified where is the point where hydrogen evolution stop? Okay, by following this line, are you able to tell where is the location and pinpoint the location by using maybe by the symbol of X? Can you do that? Okay, just take that as a take-home question for today. Think about it. If you still don't know how to answer that question, I'll answer your question next lecture. Okay? I think we'll stop here. The slides, huh? Let me stop the. Let me check if I miss out any slides there. Can you guys go on, or you guys need a short break? Okay, maybe we stop here. I will see you in next lecture on Thursday. Okay, let me stop the recording.